Okay, so basically in this topic 6.3, so we're going to discuss trigonometric equations. So you're going to be given an equation and you're going to find the solution of the equation, so within the restriction given. Okay, but before we start with solving the equation, so there are going to be certain elements that I wanted to remind you. So which is regarding our quadrant. So you have seen this before previously in 6.1 when I explained to you about the quadrant and so on, even the reference angle. But I would like to remind you about this again so that you have a clear idea. So when we use this in our calculation. Okay, so basically, so we have 4 quadrants. So at the top of here, top right is going to be first quadrant, second quadrant, third quadrant, and also the fourth quadrant. Okay, first of all, I'd like to remind you about the cos rule. So what happened is that in the first quadrant, all trigonometric equation is going to be positive. So whether it's tangent, so whether it's sine, so whether it's cosine, so every single trigonometric function is going to be positive in the first quadrant. And so how does the name cos actually come across? Because over here, so in the fourth quadrant, it's going to be, I should have explained the fourth quadrant first. So what happened is that when you come across the fourth quadrant, so every cosine function is going to be positive. And the first quadrant is going to be A, so it means A stands for all trigonometric function. And for the case of second quadrant is going to be S. So anything related to sine is going to be positive in the second quadrant. And in the third quadrant is going to be T, so which is related to tangent. So that is how the cos rule actually comes from, because of the CAST combination right here. So that is called as the cos rule. Okay, the second thing is that I'd like to remind you about how do we find for reference angle. So whatever that we're going to get in our calculation later, so that is called as being the reference angle. What we calculate from the calculator, that's the reference angle. And when you wanted to find the real angle, you have to do a certain calculation. Okay, so for the first quadrant, so this is where the reference angle going to be. So I'm going to use theta hat to refer to reference angle. But the good news is that when we are in the first quadrant, so the value of your theta, so that is going to equal exactly the same value as the reference angle, so which is going to be theta hat. So you don't have to do any calculation in order to find theta. Okay, then we come across our second quadrant. Okay, so basically if we are in second quadrant, so this is going to be your theta. Okay, so this is going to be our theta, but where is going to be our reference angle? So it's going to be on the opposite side of theta, so that is going to be our reference angle when it is in the second quadrant. So how do we find theta? For when your angle is in second quadrant, so theta is going to equal 180 degree minus theta hat. Okay, so that is going to be when you do the operation, so then only we will be able to obtain what is going to be the value of theta. And for the case of in third quadrant, so this is where your position of reference angle is going to be. And when you wanted to find the value of theta, so you have to calculate 180 degree plus the reference angle. And in the fourth quadrant, lastly, so this is the position of the reference angle, and theta is found by calculating 360 degree minus the reference angle minus theta hat. And this is the case when the answer is in terms of degree. So degree. Okay, so be careful to set your calculator in the correct unit, whether it should be in terms of degree or it should be in terms of radian. But if the calculation asks you to give your answer in terms of radian, so it's going to be a very similar idea. So in the first quadrant, still your theta is going to equal the theta hat value. But for the second quadrant, so now 100 degree converted to be in terms of radian. So that is going to be pi radian. So you can have pi minus theta hat. So in the third quadrant, so it's going to be pi plus theta hat. And in the fourth quadrant, so 360 degree converted to radian is going to be 2 pi. So it's going to be 2 pi minus theta hat. Okay, so the idea is going to be pretty much similar. It's just whether it's expressed in terms of degree or whether it is expressed in terms of radian. And please, I would like to remind you again, make sure that your calculator is in the correct unit. Okay, so now that we have all this, you're already clear about the concept that we're going to apply. So I'm going to start with the first example. So okay, and the first example, so these are going to be very simple examples. So I just give a very simple function of cosine and tangent, and here we have a restriction. So the fact that your value of theta should be a value between 0 degree and also 360 degrees. So remember, so that is going to be one, what I call that, one rotation in your quadrant. When I have a full circle moving from there to there, so this is going to be one rotation, 360 degree, but it doesn't mean that your angle can only rotate once. It could only rotate twice on the circle. So it's going to be like this. So I'm going to start I end and I'm going to start that again. So therefore what happened is that is going to be twice of that. So twice of the rotation, that is going to equal 720 degree. So how do you know whether your angle only rotate once or twice? So that is going to be based on the value of the restriction right here. So this restriction gives us two information. The first, we know that this angle is going to rotate only once on our quadrant. The second information that we had is that your answer should be in terms of degree, not in terms of radian unit. Okay, so now let's start our calculation. First for A, so we're going to find what is going to be the value of theta if cos of theta is going to equal negative 0.6691. Okay, let me find my calculator first. Okay, now let's start with the calculation. So now when we said find or solve this equation, what we wanted to do is we wanted to find what is going to be the value of theta. So therefore I'm going to move cos to the other side. So when you have cos, you move it to the other side, it's going to be the inverse of cos. So that is why now operation is going to be cos inverse. Theta is going to equal cos inverse of 0.6691. So if you notice, what happened is that previously I had a negative, but I completely ignored the sign, the negative, and I simply write over here as positive 0.6691. So it's not a mistake. I do not mistakenly leave out the negative, but I leave it out on purpose. So do not bother with the negative first. So just use your calculator for this. So calculate what is going to be cos inverse of 0.6691. So I'm going to first make sure that my calculator is going to be in degree unit, and then I press shift and cos, for which your calculator is going to give you cos inverse of 0.6691. So it's going to be a value of 48.0024. But usually we're going to take only two decimal places, but the first two decimal places are 00. So therefore I'm just simply going to write over here as 48 degree. So that is going to be the theta. But actually what you get over here, so this is not the real theta, but this is actually our theta hat, so which is actually the reference angle. Okay, so how do I find what is going to be the value of theta, the real value? So what I'm going to have to do is I'm going to have to use the CAST rule, so CAST. So first of all, so we figured out already, so the fact that when you cos the theta angle, so it's going to give you a negative value. So where are the quadrant for which the cos are going to be negative? So it's going to be on the second quadrant and also the third quadrant. So in these two quadrants, so cosine functions, they are going to be negative. So these two quadrants are going to be where our theta is positioned. Okay, so therefore theta is going to equal two values. So the first value is going to be in the second quadrant, and I know that when we wanted to find the value on the second quadrant, so I'm going to have operation of 180 degree, so minus 48 degree. So that is going to be the case in the first quadrant. Okay, and if I were to simplify this, so I will get a value of 132 degree. Okay, and next what happened is that I'm going to find the next value of theta. So that is positioned in the, sorry, this is not first quadrant, so this is actually positioned in the second quadrant. So let me correct that. So this is second quadrant, and then another angle is positioned in the third quadrant. So here I'm going to have 180 degree plus 48 degree according to the rule that we have discussed before. So therefore my second angle is going to be at 228 degree. So there's a simple way that you can actually check so whether your answer is correct or not. You can simply use your calculator, find what is cos 132 degree, and what is cos of 228 degree. And your calculator is going to give you both, are going to give you a value of negative 0.6691. Okay, so this is the way that you can actually check for your calculation. So whether the values that you get from your calculation is correct or wrong. So you can simply calculate that by using the calculator, by substituting the value of theta from what you have obtained earlier. Okay, so that is going to be our first example. And secondly, if you notice over here, so we stop at 288 because the value of theta should be between 0 and 360 degree, because if I were to make another rotation, so I would have exceeded 360 degrees. So therefore, so we're going to have only two angles. Now I'm going to proceed to the second example. So now we have tangent. So I have that tangent theta. So that is going to equal a positive value of 1.2435. So 1.2435. So the calculation is going to be similar to what we have done before. So I'm going to find theta by itself, our reference angle. So I will get that theta, or we can use theta hat to just to remind you that this is a reference angle. So theta is going to equal tangent inverse of 1.2435. So use your calculator to find. So tangent inverse of 1.2435. So that is going to give you a value of 5.19 degree. So we have 194. So therefore, when we round it up, so it's going to be 51.19 degree. Okay, so now, so we have to verify whether or not this is going to be the solution by using the CAS rule. So remember, I'm going to have CAST. Okay, for this case, what happened is that the tangent is a positive value. So here I have a positive value of tangent, and tangent is going to be positive in the first quadrant and also the third quadrant. So those are going to be the position of my theta. Okay, so therefore, theta is going to equal, in the first quadrant, it's going to be the same value of the reference angle, so which is going to be 51.19 degree. And in the third quadrant, so it's going to be 180 degree, so plus 51.19 degrees. So when I do the operation, so I will get the first one is 51.19 degree, and for the second angle I have 180 plus 51.19, so that is going to equal 231.19 degree. And of course, again, so I'm not going to make another rotation, because we already know that theta is a value that is between 0 and also 130 degrees. So if I were to make another rotation, so it would have exceeded this value. So that is why, so only these two are going to be our solution. So these are going to be our theta. Okay, so that will be the idea. Okay, so next I'm going to be showing you these functions right here. So now I'm going to, this is a very simple one, but now I'm going to try to make things slightly more complicated. So now that you already have the idea, so now we are going to discuss more complicated equations. So the question over here, say that solve the following equations again. So our solution is going to be in terms of degree unit. So from 0 until 360 degree. So our x should only be between 0 and 360. It shouldn't exceed that value of angle. So I'm going to start with A, so which is the simplest one over here. So I'm going to solve an equation of 2 sine x minus 1, and that is equal 0. Now let's start solving this. So I'm going to do is first, I'm going to make the trigonometric function by itself. So what does that mean by that? Anything that is not related to not the trig function itself, which are constant, I'm going to rearrange and put that on the other side. So therefore, for this case, I can write that. So sine x is going to equal 1. So when I move this to the other side, it's going to be positive 1. And this 2 as well, I'm going to move it to the other side. So I'm going to have sine x is going to equal 1 over 2. So basically what I wanted to do is, I wanted the trigonometric function to be by itself. And other than that, rearrange that, put it on the other side. Okay, so now that I have this form, so I'm going to use the same trick as I have used previously in our previous two examples. So I'm going to find what is going to be x. So x is going to be sine inverse of 0.2 or 1 over 2 or 0.5. So I'm going to press my calculator. So sine inverse of 1 over 2. So that gives us a value of 30 degree. So using the same idea as previously, that is by using cos rule. So here we notice the fact that here our sine is a positive number. So what happened is that sine is going to be positive either in the first quadrant and also in the second quadrant. So therefore now when I wanted to find what is going to be the value of x, so our real angle, first in the first quadrant, so it's going to be 30 degree. So in the second quadrant is going to be 180, so minus 30 degree, or that is going to simplify to 30 degree and also 150 degree. So that is going to be my two angles. So for the case of equation number 1, that is the first equation. So basically it's the same idea as previously, just that we have more constant to deal with. Okay, B, so we have tangent square now. So I have tangent square x minus 1, and that is going to equal 0. So this one, also the same concept is going to be the same as previously. First, I'm going to rearrange and make the trigonometric function by itself. So I'm going to write that tangent square x, that is going to equal 1. Okay, so I would like to remind you, so the fact that, so tangent square x is actually equivalent, it's actually the same as tangent of x being square. So it actually means the same thing. So that is why, so when I square it both sides of the equation, so I'm going to have tangent x is going to equal plus minus square root of 1, or basically tangent x is going to equal plus minus 1. So basically here, so I have plus and also minus of 1. I have two equations that we have to solve. So the first equation is going to be the case when tangent x is equal positive of 1. So that is going to be one equation. So the other equation is when tangent of x is going to equal negative of 1. But how do we solve for this? So it's going to be exactly the same idea as previously. So now let's draw the cos rule so we can identify clearly. Okay, for the first equation, so I'm put over here as first, and this is my second equation. So tangent x equal 1. So I'm going to write that x is going to equal tangent inverse of 1. And using my calculator, tangent inverse of 1, so that is going to equal 45 degree. So this is where is going to be the x position. So this is going to be where like all the angles are positive, because here I have a positive tangent of 1. So therefore, where is my tangent is going to be positive? So it's going to be on the first quadrant and also the third quadrant. So which is why, so I will get x is going to equal 45 degree. So that is going to be in the first quadrant. So in the third quadrant, it's going to be 180 degree plus 45 degree. So that is going to be 45 degree and also 225 degree. So those are going to be my two solutions when tangent x is equal 1. And I'm going to do the same for the second equation. So tangent x equal negative of 1. So x is going to equal tangent inverse of 1. Again, I would like to remind you. So when you have a negative, simply put it aside. Just take the inverse of a positive number. But this is going to be the same as previously. So tangent inverse 1 is still going to be 45 degree. But the only thing is that now, so these two angles that I'm going to solve, so it's going to be where the tangent is supposed to give you a negative value, so which is on the second quadrant and also the fourth quadrant. So therefore, where is going to be the position of x in the second quadrant? So it's going to be 180 degree minus 45 degree, and in the fourth quadrant, it's going to be 360 minus 45 degree. And when I do my calculation, 180 minus 45, so that is going to give us 135 degree, and 360 minus 45, so that is going to be 315 degree. So here none of our angle actually exceeded 360 degree. But now, so I'm going to write that I have 4 angles altogether, 2 from the first from the first equation, so which is 45 and also 225, and 2 when x is equal to negative 1, tangent x is equal to negative 1, so which are 135 degree and also 315 degree. So those are going to be my 4 solutions. And why do I have this? because my function is a square, so I have tangent square. So when I square root both sides of the equation, so it gives us two answers, which is plus and also minus. So you have to separate them and find what is going to be the angle on a separate calculation. So it's going to be easier that way, so it doesn't confuse you. Okay, so that is going to be the outcome for B. So this is going to be our second equation.